So in this video we'll be showing you how to convert reoccurring decimals into fractions. So in a previous video we talked about the types of decimal numbers you can have, and in this video what we're going to go through is how to convert reoccurring decimals into fractions. So reoccurring decimals are where the decimal part of a number is never ending, so it just continues all the way to infinity, and numbers follow a particular pattern after a certain point within the decimal point. So the size of this pattern of the repeated numbers can vary in size from just one number to many. So if we just go through the different types of recurring decimal numbers you can get, now I've kind of categorized it into 4 sections. There may be more, but this is how I've done it. So for the first one is when there's one repeated number in the pattern. So for example, we can see here that we've got 0.888 and the 8 just goes on forever. Now on your calculator, if you were to get that, you might get something like 0.888888889, and that's because on your calculator it will always round up the last digit. So even though this number is reoccurring, and if you do get a number like this, this kind of gives the impression that the number is reoccurring. Now on more modern calculators it actually does come up with the sort of reoccurring symbol, which is just a case of just having a dot on the top, or the notation, so look out for that. So another way of writing 0.333333 would be, in this one on your calculator, would be simply not the 0, I don't know where that's come from. Let's go with that. So if we had 0.333, now your calculator is usually programmed to have a certain amount of characters on the screen, so it's usually 8 or 9. So here we've written 7 characters, so let's just go for another. Now for this, your calculator won't round up, because with regards to rounding up numbers to decimal places, the number next to it isn't higher than 4, so that's why it will remain as 0.333 recurring. And again, the more preferred way of writing that is 0.3. And likewise for this one, this would be represented as that on your calculator, with a lot more 7s after a while. Now for the second variation, let's just get a different colour pen. So the second one is when you've got 2 or more numbers in your pattern. So here in this example here, you can see that we've got a 12 being repeated. Now that would commonly be represented as 0.12 with a dot above the 1 and a dot above the 2. Now the first dot represents where the pattern starts, and the second dot is where it finishes. So with regards to 0.619, so again that would be represented with a dot on the 6 and a dot on 9. If you're using dots, then you don't really need to have these additional pattern, the pattern repeated after it. Whereas for the second one for here, what you might find is you may have a dot on the second pattern, where the very last sort of section of the pattern, and go from there. But like I said, it's more often that you just have where the pattern starts and where the pattern finishes. So for this last sort of example on number 2, you'd probably write this as 0.79845 with a dot on the 7 and a dot on the 5. Now the third one is where numbers are big, the decimal numbers are bigger than 1. So as you can see in this third section, that all the numbers are bigger than 1. So we've actually got a number before the decimal place. Now what that would usually refer to is that when you are converting them into a fraction, it will be an improper fraction. So it's always worth checking your answer to make sure you've got the right thing. So if you have got a number that's bigger than 1, it will always be an improper fraction. And the last section, which is probably the hardest one of converting, is when you've got numbers in front of your repeated pattern. So for example, with 0.122 recurring, I've got 0.122. Now the repeated pattern is the 2. The 2s are what goes on forever. But unfortunately, what I have got is this cheeky one that's in front of it. So the repeated pattern starts after a certain number. So for this second example here, we've got 2.1462626, and that goes on. So here you can see that the pattern starts at the 6 and 2, so it goes 6 2 6 2 6 2. So the pointless numbers we've got here, or not to say pointless, the numbers that aren't part of the sort of pattern are the 2 1 4. And likewise with regards to this third example here, we've got 0.7515151, and you can see here that the pattern is 5 1. So the numbers that aren't part of the pattern are the 0.7. So the 0.7 bit is the bit that's not part of the pattern. So before we actually go forward to actually converting these to fractions, it is really, really important that you establish which of these four your number is to start with, because there is a slight variation in what you need to do before you in the process of converting them into fractions. So let's have a look at the steps in how to do this. So in terms of converting these reoccurring decimals into fractions, I've written down some general steps. Now, at face value, when you're reading them, it probably makes absolutely zero sense to you at all, and it's probably very confusing. Sometimes with maths, it's very difficult to write down steps. So once a teacher or once you've been shown a method, it's always good and important for you to write down your own steps for you to recall in a couple of months' time, or when you might forget, to think, right, okay, what is it to do? Because what makes sense to me might not make sense to you, and what makes sense to you might not make sense to me. So it's always important that once you've mastered a skill, is to write down exactly, with some annotated notes, what you've actually done. So let's get started. So with regards to the first type of recurring decimals, let's go for convert 0. Let's go for 6 recurring into a fraction. Now with regards to step 1, I'll try and sort of mark what each step means. So the first thing we want to do is make the number equal to x. Now one thing I'd probably suggest is to try and make sense of these. What I'm going to do is I'm actually going to write it as 0.6666 recurring as such. Now from this, the next steps, that's the first step done. For the next step, what we then need to do is ensure the pattern of the repeated numbers starts immediately after the decimal point. If it doesn't, multiply both sides by the power of 10. Now this second part doesn't really apply to this question, because in this particular question our 6 is the repeated pattern, and you can see that this is the start of the pattern, I should say, and the 6 starts straight after that decimal point. So number 2 is actually going to be absolutely fine. So I'm just going to write that out again. Let's just write this off in blue. See that? Gone for a different shade. And the third step is we're going to label this as hashtag 1. Now probably I shouldn't have labelled these as hashtags as we go, so let's just rectify that. And so what I'm going to do is I'm going to label this as hashtag 1. Now for number 3, that's step 3. So for step 4, what we need to do is we need to try and create 2 equations. Now this is one of our equations, that x equals 0.6 recurring, or this is another alternative way of writing it. So this is also our first equation. So what I need to do is I need to multiply both sides of this equation by a multiple of 10, so that the repeated pattern starts after the decimal point. Now again, saying that out loud makes absolutely zero sense. Now because there's one number in the pattern, what I'm going to do is I'm going to multiply both sides by 10 to the power of 1. So the 1 is the number of numbers in the pattern. Now 10 to the power of 1 is just 10. So I'm going to multiply both sides by 10. So if that's actually rather than, so I've got 0.6666, and so what I'm going to do is I'm going to multiply both these two things by 10. So this then becomes 10x, and multiplying by 10 I just move the decimal point one place, so I get 6.6666, and that continues. Now obviously the 6's continue. I've kept it, because I've got 4 6's after the decimal point, I'm keeping 4 6's at the end. It doesn't really make a difference, but when we move on to the next stage, hopefully it will make a bit of sense. So now, and I'm going to label this as hashtag 2. So hopefully I've not lost you. So now we've got 2 equations. So step 6 is where we need to subtract the 2 equations. So this is step 5. So step 6 is we're going to subtract hashtag 2 from hashtag 1. So we've got 10x equals 6.6666, and that recurring, and hashtag 1, which is x equals 0.6666 ... and we're going to subtract the 2. Now if I subtract these to the left hand side, I'm going to get 9x. And if I subtract 6.66666 recurring by 0.66666 recurring, all I'm going to be left with is 6. So you can see there that by subtracting these two, what we've done is we've eliminated those reoccurring numbers or the decimal part after. And what we've now got is some nice whole numbers. So from this, what we now need to do, and because I'm running out of space, let's just write number 7 here. So I've got 9x equals 6. Now step 7 says we need to make x the subject, so I'm going to take the 9 over to the other side. So I've got x equals 6 over 9, and part 8 is then simplify the fraction if we can, which gives me 2/3, and there is your final answer. So let's do another example of, let's go for 0.7 recurring into a fraction. If you want to go ahead, you can pause the video and have a go at this question yourself, and what I'm going to do is I'm just going to talk through how we do this. So the first thing we want to do is make it equal to x. The second step is the repeated pattern starts with 7, and I've got that straight after the decimal point, so that's absolutely fine. And because I've got one number in the pattern, I'm going to multiply it by 10 to the power 1, which is 10. So I've got 10x. Well, let's get rid of these numbers because it might be confusing. So the next thing we then need to do is multiply both sides by 10, in which I get, oh, I forgot to label this hashtag one because that is important. So then I've got 10x equals 7.777 recurring. I'm going to label that as hashtag 2. And then I'm going to do 10x equals 7.777 and x equals 0.777, and I'm going to take away the two things, so I've got 9x equals 7, and then make x the subject of x equals 7 over 9. Can I simplify that? No. So there is your final answer. Now when you've got more than one number in your pattern, so let's just have a look at what those types of questions look like. And let's just get rid of all of this. And let's get started. So let's have a look at 0. Let's try to set some pen first. 0.24 recurring. So here we've got two numbers in our repeated pattern. So here we start off by writing x, so 0.24. Now because I've got, now what I want to do here is, because I've got two numbers in the pattern, I'm going to multiply both sides by 10 to the power 2, which is 100. So if I multiply this by 100 and this by 100, then what I get is 100x equals, and it's going to be 24.2424, and this is my hashtag 1, this is my hashtag 2. So I've got 100x equals 24.2424, and I've got x equals 0.2424, and I'm going to take away the two things, so I've got 99x equals 24, and then make x the subject, so I've got x equals 24 over 99, which does simplify to give me 8 over 33, and there is your final answer. So you can see that when you've got multiple patterns, it doesn't really make any variation, it's just a case of doing the same. Now let's have a look when we've got a slightly bigger pattern. So all it is that when you've got a bigger pattern, it's just a case of dealing with more complicated numbers. And you might find that in your exam you might get this, but again, when you've got complicated questions, usually they imply more marks. So if your sort of understanding is there, the rewards will be there as well. So let's go for 0. Let's just pick two numbers, 816. So here we start off by x equals 0.816, and you can see, just write the add again. Now you can see the pattern starts at 8, and the first number after the decimal point is 8, so that's absolutely fine. So here you can see I've got three numbers in the pattern, so I'm going to multiply both sides by 10 to the power 3, which is 1,000. So if I multiply that by 1,000 and then multiply that by 1,000, I get 1,000. I'm supposed to have 1,000. So we have 1,000x equals 816.816816. And again, the step that I always keep forgetting is labeling this as 1 and 2. So now you can see here that basically what you need is to have the same numbers after the decimal point in both your two sort of hashtag equations. And if not, we just need to manipulate them, which we'll move on to when we look at the last example. So here what we've got is 1,000x, I keep forgetting that third zero, equals 816.816.816. And we've got x equals 0.816816. You can see here I've got nice neat columns and my decimal points are all in the same place, just so that it makes it a lot easier for me to subtract. So I've got 999x equals 816. So x equals 816 over 999, and then you just got to ask yourself, does that simplify? And your answer is going to be yes, it does, and it simplifies to 272 over 333, and there is your final answer. Now, one good way when you are practicing this, now this tends to be usually on non-calculated paper, because if it's on a calculator paper, it becomes a bit of a duff question, because especially with modern calculators, you can actually enter reoccurring numbers in, press equals, and it'll give you the fraction straight away. Or with some calculators, you could just type in, like for example, 0.816.816.816.816.816 until your brain starts getting tired. Press equals, and your calculator will automatically round it, convert it to a fraction for you. All depends on what equipment you've got in front of you. So for another example, let's go for 21. Let's go for 3,2. Okay. So again, we're going to start by having x equals 21.3232. Let's just change the colour just to make it easier for us to come on screen. And so you can see that the starting pattern starts straight after the decimal point, so that's going to be absolutely fine. So I've got two numbers in my repeated pattern, so I'm going to multiply both numbers by, both sides shall I say, by 100. So I've got 100x equals 2132.3232, and then I'm going to do 100x equals 2132.32, and x equals 21.32, and I'm going to subtract the 2, so I get 99x equals, and it's going to be 2111, and then x equals 2111 over 99, and then just all I've got to do is just check to see, does that simplify? No, it doesn't, and there is your final answer. Now this then leads us on to the more difficult types of reoccurring decimals, and they're ones where the repeated pattern doesn't necessarily start after the decimal point. So for example, if we had 0. Let's go for 3,5, with the 5 being reoccurring and not the 3. So in this particular question, as you can see, that the repeated pattern doesn't start directly after the decimal point. We've got this 3 that we kind of need to sort out first. So the first thing we need to do is, as this first step is exactly the same, is make it equal to x. Now for this, in order for the whole process and method to work, you need two equations where the reoccurring pattern is after the decimal point. So with this, what we need to do is, and this kind of all relates to multiplying by powers of 10. So if I multiplied this by 10 to start off with, then what I'm going to get is I'm going to end up with 10x equals 3.55 recurring. Now if I then took the original equation and multiplied that by, let's say, 100, then what I'm going to end up with is 100x equals, and it's going to be 35.55 recurring. Now from this you can see that in this equation here and this one here, that the 5s start, the repeated pattern, which is a 5, starts straight after the decimal point, whereas in the original one it didn't, it started with a 3. Now what I'm going to do is I'm going to use these two equations, so I'm not going to use the original number to get my fraction, I'm actually going to use these two instead. So if I write them out again, so I've got 100x equals 35.5 recurring, and I've got 10x equals 3.5 recurring, and I'm going to take those two equations away, so I'm going to end up with 90x, and I'm going to end up with 32. And then if I then make x a subject, so I've got x equals 32 over 90, which simplifies to give me 16 over 45, and there is your final answer. So there's just that little tweak. So in this final example, the only thing you've got to be aware of is that you're not actually going to use the original number when you come to actually formatting your fraction. When you come to this bit here, what you kind of need to do is create two equations yourself and then go from there. So if we have a look at another example, just so we can finish this up, and let's change this as quickly as possible. And like I said, these kind of marks at GCSE exam usually carry about 3 to 4 marks, depending on how much work is needed. If it's a simple decimal, it's going to be less marks. If it's going to be quite a complicated one, then it's definitely going to be worth a little bit more. So let's have a look at 1.245 with the 4, 5 being reoccurring. So here again, we start off by making it equal to x. So I've got 1.245 recurring. So what I want to do is I want to multiply both sides by powers of 10, so that the 4, 5 starts right after the decimal point. So if I start by multiplying this by 10, I'm going to get 10x equals 12.45, and that's being reoccurring. And then if I then multiply this by 100, now you could multiply by 1,000, it's entirely up to you. Shouldn't really make much difference, it just requires a little bit of work. So I've got 100x equals, now for this, actually we'll need to multiply by 1,000, because if I multiplied by 100, sorry, so if I just write this out, I'll explain to you what I'm doing. So if I multiplied this by 100, then what I'd end up with is 100x equals, moving it 2 places, I get 1.124.545. Now as you can see, this pattern is different to this one, so I need to make sure the patterns are the same. So actually what I need to do is, I would like to say I made a purpose mistake, but these mistakes do happen quite often, is to multiply it by 1,000, so I get 1,000x, and I'm going to end up with 1245.45 recurring. So this is now my hashtag 1, this is now my hashtag 2. So from this I've got 1,000x equals 125.45, and I've got 10x, which is 12.45. I then take away the two equations, so I end up with 990x equals, and it's going to be 1233. And then convert that into a fraction, I get x equals 1233 over 990, which looks right because it is going to be an improper fraction. So all I need to do is check to see, does it simplify? And the answer is yes. So it's 137 over 110, and there is your final answer. Now if you wanted to convert that into a mixed number, that would be 1 and 27 over 110, and there is your final answers.